So now let's talk about how to take the average value of a function that's maybe not just plain flat lines on some x interval. We can apply the same idea as before, break it up into small boxes and then add up the boxes. So let me relabel this a value, we'll call that x1, and then we'll have another x value here called x2, and I'll draw a box like that, and then I'll draw another box like that, etc. So what's the total of those boxes? You see I'm kind of approximating the curve with a bunch of flat lines, almost like sampling it statistically, but not randomly sampling it very regularly. So we could say, what's the total area of those boxes? You could say it's f of x1, that's the height of that box, times delta x1, which is x2 minus x1, plus f of x2 times delta x2, etc. We could write all that in summation notation, say starting at I equals 1 going to n, f of xi times delta xi. Hopefully this is looking a little familiar. And then if we let all the boxes get infinitely narrow, or say we have a near infinite number of them, so we'll say as the box widths go to 0 and n goes to infinity, what we're getting is the integral of f of x dx from a to b. So is that the area? Well, that's the area, but is that the average? Now for the average, we need to divide by the sum of the weights, so to speak. And the average is what's the total distance there, 1 over b minus a, times that integral. So taking an average is basically just as easy as taking an integral, or hard, but then you just divide by b minus a, which a lot of people forget to do when they're doing the homework. They just report the area and then forget to divide by the length of the interval. So I'll highlight this as the length of the interval. All right, so let's talk about it some more in the next video.